Hi, my name is dr. Ahmath. In this lecture, we're going to discuss about the radicals, or we are going to try to understand what is this number. Previously, we talked about the exponentials, and it was more or less straightforward to understand and calculate. Because whenever we say that, hey, what is the square of 3? This is going to be just the multiplication of the 3 to itself twice, which is equal to the 9. And what we would like to do is we would like to answer to the following question. So this is kind of the forward question, and I would like to answer to the inverse question. So what is the square root of 9? So in this case, I'm asking you, hey, could you please tell me a number whose square is equal to the 9? So the question is, tell me a number the square of which is equal to 9, right? So in this case, the answer is going to be equal to the 3. So square root of 9 is equal to the 3, since the 3 in the square is equal to the 9. So this is, you can feel here that we are doing the inverse operation, right? So here we're answering to the forward question, and here we're answering to the backward or inverse question. So in general, we are going to define the radicals like this. It's going to be a of root n's power, or the root of a in the n's power. And the question is again, so tell me, so if you would like to get rid of this radicals, right? So the answer would be, tell me a number so that a number x, let's say. So tell me a number x so that x in the power of n is equal to the a. Okay, so this is the question. So before we're going to proceed to understand the properties of the radicals, I would like to show you a couple of examples. So let's do a couple of examples. So let's start with the easier ones, like let's say I would like to find, again, the square root of 16. So please know that whenever we are dealing with the square root, so we assume that here there is a 2, but we're not going to just write this, since the square roots are commonly used, like the most popular radicals, and we're just not going to write a 2, but it is assumed that there is 2 there. So the square root of 16 is equal to the 4. Please note that this is not going to be plus minus 4. It's simply going to be simply 4. So since the square root is going to be assumed to give you a positive number. So this is equal to the 4 because 4 in the power of 2 is equal to the 16. So let's do another example. So example number 2. So let's say I would like to find the cubic root of -8. So here I need to put the 3. So again, so I would like to ask you to tell me what is the cubic root of -8, right? So if you want, you can just leave your calculation in this stage, but I would like to get rid of this radical. So in order to do this, I would like to figure out a number so that if I multiply that number to itself 3 times, it should be equal to the -8. Can you guess what number is this? So this is going to be -2, because -2 in the power of 3 is equal to the -8, right? Okay, so this is what does it mean, the radicals, and we can continue working with this. So let's say, so please note here that the number which is inside the radical can be negative sometimes when we are dealing with the radicals of the odd powers, right? So here 3 is an odd number. But if I would like to find the -16 and its square root, right, where its power is going to be an even number, then in this case there is no real answer. There is no real answer. Okay, so what does it mean? So the constraint is like this. So I'm going to define the radicals of the n's power like this. So this is going to be a radical of n's power, right? So if n is an even number, then a should be positive, okay, or equal to 0. So if n is odd, so for a here, it's going to be if n is an odd number, it's okay that a is negative as well. So a is any real number. A is going to be any real number. Okay, so what we would like to try to understand is I would like to relate the radicals and exponentials through some equations. And then we are going to talk about the properties of the radicals. So if you remember, so we've got the law for the exponentials. And the law was like this. So if I have an exponential number, a in the power of n, if I just power this number to the m's power, this can be calculated as a in the power of n times m. So I'm going to use this property in order to connect the radicals and the exponentials. So let's say I've got a radical, so a n here, right? And let's assume that this number is going to be equal to the x, right? And I would like to find this x. So what does it mean, finding this x? It means that if I power this x to the n, it is going to be equal to the a. This is what does it mean, the x. I'm looking for this x so that the n's power of the x is going to be equal to the a. So we did this previously in our examples, right? Okay, so what I'm going to do is I'm going to get this equation and I'm going to take the rational exponentials from both of the sides of this equation. So basically I'm going to get the rational exponential 1 over n from here and 1 over n from here. So please note that, so let me rewrite this again here. So I'm going to write this to here. So it's going to be a in the power of 1 over n, right? And this is equal to, so x in the power of n in the power of 1 over n, according to this rule, is going to be just the multiplication of this n to the 1 over n, which is equal to the 1, right? So this is going to be x in the power of n times 1 over n, which is x in the power of 1. Right? So I'm going to just write this here. So simply x. So please note that this equation and this equation are the same. And I see that this x and this x are the same. So that is why this notation and this two notations should be the same. So it basically gives me an equation that the root of a of n's power is going to be equal to the a in the power of 1 over n, which is like super important equation, which is going to relate the radicals and the exponentials. So it appears I can connect exponentials with the radicals right immediately using the rational exponentials, right? Basically using some rational numbers here. So let me write a couple of notations. So let's say if I would like to, let's do a couple of examples. So if I say, hey, what is going to be x in the power of 3 over 4, right? So we can write this down in terms of the radicals or using the radicals. So this is going to be x cubed in the power of 1 over 4, right? So we know that this is going to be x cubed. And here we're going to have the root of the power 4, right? Let's do another example. So let's say I would like to rewrite this kind of like 5 here and x in the power of 27, for example. So this can be written again. So x in the power of 27 in the power of 1 over 5. And then it's going to be x in the power of 27 over 5. So this formula actually is really important, which connects the exponentials and the radicals. So let's talk about the properties of the radicals. So previously we used to have, so the properties the property for the exponential. It was like a in the power of n times a in the power of m is equal to the a in the power of n plus m, and which doesn't work for the radicals. So basically, if you have the a square of a of the n's power times to the square of a of the m's power, this is not going to be equal to the square of a of the n plus m's power. So let's see why. So the a of square root of a of the n's power is going to be a in the power of 1 over n times the root of a of the m's power is going to be a in the power of 1 over m, right? So according to this rule, it's going to be equal to the a in the power of 1 over n plus 1 over m, which is not simply 1 over n plus m, right? Which is going to be a in the power of n plus m divided to the n times m. So in the sense, it's going to be written as like the a in the power of n plus m taken the root of the power of the degree n times m. So which is a little bit more complicated. So this equation doesn't work, okay? And similarly, so we used to have this kind of another low, like a in the power of n and the power of m, which is basically is going to work. In this case, it's going to be a in the power of n times m. So for the radicals, it's going to be a in the power of taking the root of n's degree, then taking the root of m's degree, so which is going to be more or less the same. So it's going to be, so it's going to be a in the degree of n times m, because we're dealing with the multiplication, not the addition. So what does it mean? So let's write this. So the root of a of the n's degree, it's going to be a in the power of 1 over m, right? So taking the root of the m's degree. So the root of m's degree is going to be a in the power of 1 over n. This is 1 over m. So we know that according to this rule, I can just multiply those powers. It's going to be a in the power of 1 over n times m, which is going to be a in the power of n times m here. So let's do a couple of examples in order to understand these two rules. So the first example is going to be, let's say, I need to take the square root of x, right? And multiply this to, let's say, to the cubic root of x. So please note that this is not going to be simply the x of the 6th degree, right? So because x square root is going to be 1 over t times x of the cubic root is going to be 1 over 3. This is going to be x in the power of 1 over t plus 1 over 3, which is x in the power of 5 over 6, which can be written as the x in the power of 5 divided to the, or not divided, taking the root of 6 power. Okay, this is the first example. And the second example can be written as like taking the square root of the cubic root of x. It's going to be simply x of the root in the 6th degree. So here are the examples of the loads of the radicals. So please note that the calculating or getting rid of the radicals is a difficult process. It's not like in exponentials. So while in exponentials, it is everything a straightforward process. We need to just calculate this by multiplying the numbers to itself many times. For the radicals, it's a little bit difficult process. So in our next lectures, we're going to discuss about the things connected with the radicals and exponentials.